Hello everyone, myself Dr. Aditi Chatterjee. So today topic of discussion is Routh Hurwitz stability criteria. So this is basically a continuation of the previous lecture or previous topic. So Routh Hurwitz stability criteria, and we will be discussing a special case. So here, the special case, in this special case, what we have, suppose if you have the first element of any row of the Routh array as 0, then how we can construct or how we can complete the Routh array. So the example is given likewise, such that we'll be getting an element in the first column as 0. So let us find the stability of the control system having characteristics equation as s to the power 4, 2s cube plus s square plus 2s plus 1 equal to 0. So in the very beginning, what we have to write? We have to write the first higher order of s, so s to the power 4, then we will complete it till s to the power 0. Now the coefficient of s to the power 4 is 1. So that is written here. Then alternate, that is also 1. Okay. Then alternate, that is also 1. Okay. So 1, 1 and 1. Then we will take the coefficient of s cube. So that is basically 2. And then here also we have 2. So now as we have both the elements as 2, we will take common and we will make it 1, 1. So now we have constructed the first 2 rows of the Routh array. For the next element, what we have to do, we have to calculate what is the formula. 1 into 1 or negative determinant minus 1 into 1 by 1. So obviously that will come as 0. Here we are getting 1 into 1 minus 0, as there is no element, so that will be considered as 0. So 1 into 1 minus 0 into 1 by 1, so that comes 1. Now in this row we are getting a 0. So what we can do now, what we will do, we will replace these by an element which is known as xi. Now this is xi is very small, and we will replace that xi by 0 by xi. So now what we are having here, in place of 0, we are having xi. Now, so now we can calculate the this element in this row of S1. Sorry, in this row of S. So now if we replace this 0 by xi, so that will be xi into 1 minus 1 into 1 by xi. So the element we are getting here is xi minus 1 by xi. Now how we can get this? Xi minus this element into 1 minus 1 into 1 by this element into 1 minus 0 into xi by this element. So obviously we'll be getting 1. So this completes the first column of the Routh array. Okay. So now we know that xi tends to 0 because we have replaced xi by 0. 0 by xi. So as xi tends to 0, the Routh table becomes like this. Means if you replace this xi by 0, then this element will be 0, and obviously here we have got xi minus 1 by xi. So that comes as minus infinity. And then we have 1. Now there are 2 sign change in the first column of Routh table. Hence, the system is unstable. So first we have to complete the, suppose if you got a 0 in a particular row during constructing the Routh array, you have to replace that by xi, which tends to 0. Then you complete the Routh array. Once completed, then put the values of 0 in places of xi. Then see how many sign changes are there. If there is no sign change, then we can say the system is stable. But here we can see there is one sign change, that will imply the system will unstable. Apart from that, if you get 0 in the first column, that implies that there is some roots located in the j omega axis, and that implies the system is marginally or critically stable. Now this is another special case on Routh array where all the elements of any row of the Routh array are 0. When suppose you are constructing the Routh array, and in the previous case we have seen that one element in a row is 0, but in this special case you will be getting the whole complete row as 0. Then what we have to do? So we are constructing the Routh array. We have discussed already how to construct the Routh array, means the first two row. So once constructed, then how to calculate? Once we are calculating that, we are getting, see here, the total row as 0. Both the elements of this row is 0. Then what you have to do? You have to write the equation for the previous row. So this will be s to the power 4 plus s square plus s to the power 0. So basically the equation for this line will be s to the power 4 plus s square plus 1. Now once formed, then how we can get s cube? If we do derivative. So here if we are getting here as equal to s to the power 4 plus s square plus 1. Okay, we are forming this auxiliary equation. Now once formed, we need to get s cube. So how we can do that? By derivative. So differentiating the above equation with respect to s, das, ds, we will get here 4s cube plus 2s, right? Now for 1 it will be 0. So 4s cube plus 2s. Now we can write the coefficient of s cube as 4 and 2. Now we can take common 2, so this will be 2 and 1. Now you can construct by, now we are having the elements of this row. So once you have these elements of this row, you can proceed with completion of the array. So then we are again completing the array. 2 into 1 minus 1 into 1 by 2, that is giving 0.5. For this 2 into 1 minus 0 into 1 by 2, so that is 1. So likewise we are completing the Routh array. Now here, see, here we are getting a sign change. As there is a sign change, that implies there will be roots in the right half S plane and the system will be unstable. So here we discussed two special cases, that if a particular element in a row is 0, how to complete the Routh array. And if you get the total row or all the elements of a particular row as 0, then also how we can complete the Routh array. Now, once the Routh array is complete, from the number of sign change, you can comment on the stability of the system. So these are the two very common special cases in a Routh array which you need to practice. Okay. Thank you. See you in the next lecture.